In 1936, Germany hosted the Summer Olympics under the dictatorship of Adolf Hitler. This event supplied an opportunity for worldwide Nazi propaganda to be distributed prior to World War II. In this same year, 24-year-old mathematician Alan Turing invented a theoretical machine that would change history in a comparably significant manner. He names it the Turing machine. The basic parts of a Turing machine require a tape, a head, a table, and a state register. The Turing machine requires an infinite amount of tape where symbols may be written and erased. The head is to read and write symbols. This example reads the information with a camera and writes information with a dry erase marker. This is a table of instructions. It carries out the commands and tells the machine when to erase or write. It also moves the head left or right and assumes a new state as prescribed. This action is represented by the control panel. The state register stores the state of the Turing table. It is intended to replace the state of mind of a human operator. This example uses memory cards that hold text files of instructions to be carried out by the table. The symbols in this machine don't necessarily have to be numbers. They could be anything. The idea is that anything that can be written down and converted to symbols has the potential to be carried out by one machine. September 1st, 1939. Hitler invades Poland, marking the beginning of the Second World War. At the start of the war, Nazi Germany employed a tactic that was virtually impossible to defend against. This attack engaged a complex procedure where German submarines were being guided to their target by encrypted radio instructions. These messages were coded and translated with a highly sophisticated device, the Enigma machine. The Enigma machine can be broken down to its four core functions: the keyboard, the lamp board, rotors, and the plug board. The keyboard is where you type the text you would like to have coded or decoded. The lamp board displays the ciphered text. If I type an X on the keyboard, the lamp board displays an S. For added security, there are four rotors that move with every entry of a character. Each of these rotors must be placed in a specified order to be correctly coded or decoded. If the rotors are not in the same place, when I type the X this time, the lamp board shows a G. The plug board was the final security feature which affected how the keyboard communicates with the lamp board. Much like the rotors, these wires must be plugged into the proper channels in order to obtain the desired result. It was understood that the Germans could very well have won the war if these codes would continue to be effective. The English government dedicated a group of mathematicians and cryptographers to crack this code. The team was headquartered at a secret facility in Buckinghamshire, England, known as Bletchley Park. Alan Turing, now age 27, was asked to join the team. Turing accepted the challenge and was able to solve the Enigma code within the first few weeks of his arrival. Turing's solution to the German code required inventing an electromechanical device known as the bomb machine. This machine simulated the Enigma machine and was able to manufacture all possible scrambler settings. The bomb employed a new frame of thinking that is now known as heuristics. Heuristics is an artificial intelligence term used to cut down the amount of searching required by a machine. It wasn't precise, but was accurate enough to be useful. Operators understood its instability and were encouraged to try settings that were in the vicinity of the base position. It was understood that cracking this code contributed greatly to the Germans' loss in the Second World War. After the war, Turing was able to focus his work on future technologies. He believed intellectual activity consists mainly of various kinds of search. Alan Turing looked at computers as if they were children. Children are able to absorb information, so why not computers? He dreamt of a program where you could type in words, and then the machine would be able to type and print those same words. Then he thought, if a machine could do that, Perhaps one could type in words and the computer could be programmed to type a response. This would act as a pretend conversation with a machine. And if the machine were even more powerful, you might be able to have an actual conversation with it. Better yet, perhaps the machine could become sentient. At this level, Turing thought that turning the machine off might be considered murder. Turing referred to this concept as machine intelligence, which is commonly known today as artificial intelligence. Alan Turing's contributions to society and science have just as much relevance today as they did in his time. The terms Turing-compatible and Turing-equivalent are still used in present time. Each and every modern computer is considered to be Turing-equivalent. Today's machines increasingly become more powerful, yet they continue to follow the guidelines expressed by Turing almost 80 years ago. Alan Turing continually challenged his own theories. He set forth challenges for himself, and more importantly, for future inventors and scientists. His most famous challenge is known as the Turing test. To this day, it is yet to be matched. An example of the test places a computer in one room and a human in another. The two are then required to communicate with one another. Let's say the human and computer are communicating in a chat room. Turing's test insists that the human believe that they are communicating with another human, not a computer. This experiment must be repeatable and random. Once Turing's desired result is achieved, a computer will have successfully obtained artificial intelligence. Turing not only created challenges for his peers, he was known to challenge himself. He would create examples of equations that could not be solved even by his theoretical machines. This study showed his value for human thinking, but more importantly, Turing was suggesting that these are the very issues that must be resolved before machines can truly think like humans.